Hi everyone, I'm Taysa Brown, the Silviculture Performance Assessment Specialist with the Forest Science Planning and Practices branch. In this video, I'll teach you how to do statistics by hand and fill out the FS1138A. To do that, I'll walk you through a quick example. So this example will involve a 4.5 hectare standards unit. The surveyor did 5 3.99 meter radius plots, and their plot tallies are shown in this table. We have one plot with 5 well spaced, then 7 well spaced, 2 well spaced, 4 well spaced, and 3 well spaced. This standards unit has a target stalking standard of 1,200 stems per hectare and a minimum stalking standard of 700. From this information, you need to determine the SU stalking status and make a recommendation. To begin, you're going to want to print off a copy of the FS1138A. And you can find this on the Silviculture Survey's website under the Field Cards section. Then you're going to want to fill out all the known information like opening number, stratum number or letter, area, and number of plots. After that, you're going to want to review the well space numbers. If any of your well space tallies exceed the M value, then you need to reduce it down to the M value. So for our example SU, our TSS is 1,200 stems per hectare. So our M value is 6. You'll notice that plot 2, oops, I lost my mouse. Plot 2 has 7 well-spaced trees, so we have to knock that down to 6 for our statistics. So for all subsequent steps, we're going to use 6 for plot 2. Okay, so for our first calculation on this card, we have to determine the average well-spaced density, otherwise known as the mean. So to do that, you just have to add up your well-spaced tallies across all plots and then divide that sum by the number of completed plots. So for our example, it's 5 plus 6 plus 2 plus 4 plus 3, which equals 20. We then divide that by 5, the number of completed plots. So that gives us 4 well spaced as our average. Now, if you want that in stems per hectare, you then just have to multiply that by the plot multiplier. And you can see it's actually shown right here. You take the mean and you times it by the PM plot multiplier. So our plot size was a 3.99 meter radius plot. So our multiplier is 200 stems per hectare. So we go 4 times 200 equals 800 well-spaced stems per hectare. And again, I just want to emphasize that you have to use the MCAT values for stats, and that's why I used 6 here instead of 7. For our next step, we have to calculate standard deviation. Now this is the hardest step, but it can be made easier if you use a statistics calculator. Unfortunately, the steps for calculating standard deviation will vary based on your calculator model. So I can't explain it for you here, but there's tons of great tutorials on YouTube if you search your calculator model number and type in standard deviation. Once you find a good video, I'd recommend writing out a little cheat sheet for the future and taping this to the back or the inside of your calculator. Now, if you can't figure out how to use your calculator's standard deviation function, then I can teach you how to calculate this by hand. It's a little slow if you have a lot of plots, but it's not bad if you just have 5. And as a hint, during the exam, you'll only need to do stats on strata with 5 plots, so it's not too challenging. Okay, so here's a slide where I teach you standard deviation by hand. Again, if you have a stats calculator, you figured out how to do it by using the stats calculator, you can skip this slide. But for everyone else, the first step of determining standard deviation is calculating mean. And we actually already did that previously. It's 4. Now, for the next step, we simply have to subtract the mean, 4, from each of our plot well-spaced tallies. So our first plot had 5 well-spaced trees. We go 5 minus 4. Our second plot had 6 well-spaced trees. So we go 6 minus 4 equals 2. Next plot had 2 well-spaced trees. So 2 minus 4 equals minus 2. Then 4 minus 4 equals 0. And 3 minus 4 equals negative 1. For our next step, we have to square each of these values. So that just means that we have to times it by itself. So first we have 1, so we go 1 times 1 equals 1. For our second plot, we have 2, so we go 2 times 2 equals 4. Negative 2 times negative 2 also equals 4, because it's a negative by a negative equals positive. Then we have 0 times 0 equals 0, and -1 times -1 equals 1. So we add this up now. So 1 plus 4 plus 4 plus 1 equals 10. Now for our next step, we have to take that value and divide it by the number of completed plots minus 1. So we did 5 plots. It's written down here. We go 5 minus 1 equals 4. And then we go 10 divided by 4 equals 2.5. Now for the final step, we just have to take the square root of 2.5. So on your calculator, you just need to look for the symbol that looks like this and hit it, and then 2.5, and the value that you get is 1.58. So that is your standard deviation, and we record it right here. Okay, next we have to calculate standard error, and the formula is actually shown right here. And hopefully the color coding will help so that you can find kind of what you're using within these formulas, but it's a purple S, so we find that's standard deviation, and it's divided by the square root of a blue N. Blue N is right here, number of plots. So let's give that a go. So our standard deviation is 1.58, and we divide that by the square root of our number of plots, 5. So square root of 5 is 2.24. 1.58 divided by 2.24 is 0.71. So our standard error is 0.71, and we write that down right here. Okay, the next step on the card is just looking up t-value, and this is really simple. You just go to the stats table in the FS660, and on the left-hand side, you'll see t-values. So to do this, you just look up the number of plots you completed. So for us, it's 5. And then you just see the corresponding t-value in the left-hand column. So if you've done 5 plots, then your t-value is 2.132. And so we write that down right here. Okay, next we have to calculate confidence interval. So to do that, we have to multiply out standard error by t-value. And you can see the formula for that is shown right here. So let's give that a whirl. So it's 0.71, our standard error, times 2.132, our t-value. That gives us 1.51. So we write that down right here, and then you can see that it shows that you should multiply that by the plot multiplier. So 1.51 times 200 equals 302 stems per hectare. So we write that down here. We can now use our confidence interval to calculate our lower confidence limit. So for that, we simply go mean minus LCL. So our mean was 4. So we go 4 minus 1.51 equals 2.49. Now if we multiply that by the plot multiplier, that gives us 498 stems per hectare. So our lower confidence limit is 498. Okay, next up on the card, we just have to write down our MSS, which is 700 stems per hectare, and then we need to work on desired precision. So it explains how to determine precision right here. Basically, if your mean is greater than 1,000 stems per hectare, then it is 10% of your well space or free growing mean. So if your free growing mean or your well space mean is 1,100, then your precision would be 110. In contrast, when your mean is less than 1,000 stems per hectare, which is our situation, our mean is 800, then your desired precision is set at 0.5. And if you multiply that by your plot multiplier, that equates to 100 stems per hectare. Okay, next we have to do some statistical analysis to determine the stocking status. So for this step, you're going to want to follow the steps in the survey manual, and they basically boil down to 1. Are the mean and LCL greater than the minimum stocking standard? So for our example, our minimum stocking standard is 700 stems per hectare. Our mean is greater, given it's 800 stems per hectare, but our LCL is 498 stems per hectare, so it is less than the MSS. So the next question, is the mean less than the minimum stocking standard? And we just answered that, no. Our mean is 800, our MSS is 700 stems per hectare. So we then go to the third question, which is your mean greater than the MSS, but the LCL, the lower confidence limit, is less than the MSS? And that is our situation. Our mean is 800, the MSS is 700, and our LCL is 498. Given that, we have an uncertain stocking decision. So we have to keep working through the additional steps listed in the survey manual. So when you have an uncertain stocking decision, you then have to check if max plots have already been established. So the maximum plots that you would ever do is 1.5 times the stratum area. So our stratum size is 4.5 hectares. We have that right here. So we go 4.5 times 1.5 equals 6.75. And you have to round up, so that's 7 plots. We've only established 5 plots, so we have not done max plots. So given that, we now have to move on to the next step, which involves comparing the confidence interval to the desired precision. So our confidence interval is 302 stems per hectare, and our desired precision is 100 stems per hectare. So our confidence interval is greater than our desired precision, and so that means that we need more plots. Okay, so to figure out how many more plots are required, we're going to use the formula that's listed right here. It relies on standard deviation, t-value, and your desired precision, your e-value. So the formula requires you to multiply your t-value, 2.132, by your standard deviation, 1.58, and then we're going to divide that by the precision, 0.5. So to start, let's just do the 2.132 times 1.58. That gives us 3.37. Now we do the 3.37 divided by the precision of 0.5. That gives us 6.74. Now you'll notice that this formula, it is being squared. So we have to times 6.74 by itself. So 6.74 times 6.74 equals 45.4. We round that value, 45 plots. So this does not mean that we need to do 45 plots for our stratum. We have to now just compare that to the maximum number of plots that you would ever do, which is 7. So that is what we will actually need to do. And that doesn't mean that we do 7 more plots. We've already done 5 plots. It means that we have to do 2 more plots to hit the maximum, which is required for precision. So our final recommendation on the card would be uncertain stocking decision, complete 2 more plots. Okay, that's a wrap. To conclude, I'm just going to highlight a few key points. First one being that the FS1138 is a great tool to help you do stats in the correct order, and many of the fields actually include the formulas like standard error and confidence interval. And if you're learning stats to write the accreditation exam, you're actually going to be provided with a copy of the FS1138A whenever you're expected to do stats. My second point is just to remember that whenever you do stats, you need to make sure that you're using M-capped, well-spaced, or free-growing tree counts. Third point, if you found the standard deviation formula confusing, because it is pretty long, then buy a stats calculator and learn how to use the standard deviation function. It's not too hard if you watch a YouTube video on your specific calculator model. My fourth point, make sure that you always calculate max plots. If you've already done max plots at the point of doing your statistical analysis, then you won't need to consider precision or calculate the new n value. And my fifth point also relates to that. If you are calculating the new n value, that's how many plots you would need to do in total. So don't forget to account for the plots that you've already done when making your final recommendation. And lastly, if you're watching this in prep for the accreditation exam, don't forget that it's an open book exam, so make a cheat sheet. You don't need to have this all memorized.